This is a tutorial on how to use Max MSP. Supposedly Max is kind of invented for musicians, number one, to make scheduled scores or automated rhythms in their score. But they got rid of that object back at like Max 4 or 5 because no one was using Max that way. People were just making Tinker Toy algorithms. So Max is made with object boxes. This is an object box. You can make an object box by pressing N for new. If you put in something you're supposed to put in, it will turn black. If you put Flibberty Gibbet in, it'll stay unmade. There's a giant list of 200, 500 objects that you can make. They have inlets and they have outlets and they're connected. That's the flow of data. In pink is presentation mode. That's when you're kind of performing or using the software. And then edit mode is when you're messing with the software, changing it. Everything's malleable. Every time you change it, you're sort of recompiling a C++ program. So they have some concepts like this is a patch window. Each one of these boxes theoretically could be another patch window, so you could double click on them to enter them. But if they're hardwired with C code, you can't go into them, although that would be kind of fun. They have integration with Java and other programs. Maybe they made this thing called Gen, which just lets you write programming that supposedly is higher efficiency than these abstractions. They're called abstractions if you make them yourself. You could make one yourself by going new, P, give it a name. P stands for patcher. And then it opens a new window. In this new window, you can make stuff. If you saved this window with an inlet, I could save it and call it I'll call it MM. MM wouldn't have existed until I made it. Oh yeah, you have to also make sure to save it in the file path. And you might even have to recompile the file path, you never know. But I digress. This patch shows you some of the product properties of Max. This is a send. Let me zoom in so you know what I'm talking about. Notice there's a 400 millisecond pipe, so whatever happens here via user input or from the send receive pipeline. So it's going to go from 1 to 2 to 2 to over there to over there. And the coolest thing about it is you can have over there go multiple places. And this is just the example of how to use a message box. A lot of these objects have special commands. When they receive a command, then they activate that functionality of themselves. So the whole idea here is just you go in a message box, and this is prepend hi, underscore hi, and then adds the hi to the beginning of the message. Over here, you can do it with any input, tangible, intangible, floating point, integer, or string. That's a string. In Max, sometimes they're referred to as symbols. So notice it gets I prepend. You can use me to send command, and then an append sound easy, right? So it makes the whole thing. So you can append and prepend messages together to create any message. Some parts automated, some parts malleable. Over here is the bang. These are bangs. This is a UI object. It's a feedback object. Lets you see. This is a bang. B stands for bang. Heck. You could also just make a bang. They're all the same, right? Nope, bang's not an object. I like to use the underscore or the dot, but dot's like a symbol specific to Macintosh, so they don't want to let you use the dot. But notice I double click on it and it opens up an encapsulated B. So you can change the language. Any of the object's names, you can just embed that object in a different object that you enjoyed the name of more. So it's very user rewritable in different ways. So down here is a trigger bang bang trigger right here. It's like scheduling, so that it's going to send out a row of Bs, a row of bangs. I believe there's another example later on where we'll show that you can do bangs, or you could do other stuff like floats, ints. We'll get to this stuff. Oh, here it is. So this stuff moves through. The 22 would go there, the 22.1 goes there. So that means trigger, if there's a bang going through, it goes there. If it's an int going through, it goes there. If it's a float going through, it goes there. So in that respect, this can parse data. So trigger is pretty cool. I never used trigger for that. I use other objects like cell, select. As a lot of these objects have shorthands because no one wants to write full words. They just want to abstract. So there's a T command, there's the B command. You know, it's pretty abstract. But notice this thing. It's sending out these bangs, and then counter is just counting from 1 to infinity. Every time it gets a bang, it puts out another number. And I click it, and then all those numbers in a row go up. And it's just about the routing here. So this is an int box, integer. You could write int. It's got an left inlet and a right inlet. If you trigger the right inlet, it's passively storing that in memory. Then you have to send a bang to the left inlet to output the stored memory of an int. You know, like 256. What's that? Maybe like an 8-bit number, or 16-bit number. You know, the biggest number it could probably go up to is like a bunch of zeros after a 1. And looks like it went to a negative value because it went beyond its maximum. Fun. So float is a decimal point number, maybe down to 7 decimal points. You know, same as this. It's probably got 64-bit memory. Over here we got pack. Pack is cool. It puts together collections of memories or messages. So notice how this pack is receiving an int and a float, but it outputs a float and a float quite well. It loses its floating pointness. It turns back into an int. If you specify that it is a floating point world that you're inhabiting, then floats can make it through. And notice that integers turn into floats, as redundant as that might seem. Down here is pack being used in a 2 state, in a 3 state, in a 4 state. Those extra data points are just disintegrated, truncated. Moving on. This is the user interface for gates, switches and gates. They're pretty cool. You're going to use them one way or the other to route data. So switch means I'm going to take 2 things and put them one place. One thing or the other, one at a time. And then gate lets you take one thing and put it 2 places. I happen to use gate a lot more often. They're sort of the same thing, though. The different versions of it, see, like switch lets you go, if you press 0, then nothing can go through. If you press 1 on the first inlet, then the second box, the second inlet, which is the first like data point, goes through. If you press 2, then the second data point goes through. Same as the UI graphic. gate all by itself is either, well, it goes through with a toggle at nothing, toggle at 1 lets the info go through. Gate 2, notice the gate can only go one place. Gate 2 lets you make it so that gates could go 2 different places. Check this out. I think you got gate 3. You got gate 3, you got gate 4. Pretty cool, huh? It'd be nice to make a graphic user interface. That's called the, oh, that's a message box. I press M for message box. I want a new object box. If I press G gate, that's the graphic gate. That gets me that thing. If I press G gate 3, they didn't invent that as a graphic device. But you can get a gate 17 if you really wanted to. Whenever you set this to 11, you'd send the data out the final point. So let's walk it again, move back and see what's left, what's next. So randomosity might be interesting to learn about. Uzi is like an automatic rifle that just sends out 100 bangs. Out this left inlet sends out bang, outlet that sends out bangs. Out the right outlet it sends out the index number. So it'll go from 0 to 100. I don't know what the middle does. What's the middle do? Done carrying. Okay, so once it's over, that's the trigger to say I'm completely done. Useful. Okay, so if I press this, this is called a collection. A collection is a data set list of numbers. Let's just select all and delete it and say save. So now if I double click on it again, there's nothing. If I press this button just once, it is now inhabited with 100 entries, random. They might have overwritten themselves because it's not a unique random number. That's the URN object. This is just random. So there's some entries. And there are 2 variables in each entry, so it could be x, y points. Now if I press renumber, it's going to change that chaos for the first number, and it goes up to 63. So that means there were 63 unique numbers in the random selection of 100 numbers. And so that means there's about 37 rewrites. Now if I had changed this to earn 100, it'll still chaotically choose 100. But it chose every single one. It had to. So if I do renumber on it, there should be 100 entries. 99. 0 to 99. Ain't that nice? Yeah, so it chooses a random number. And chooses a random number. And chooses a random number that's unique. Packs them together. And the first variable in that set is the index number. If I press this, it'll output whatever's at that index number. If nothing's at that index number, it doesn't output anything. Okay, so this gets into a little bit time feedback. This one is a bucket brigade of pipes. So when I put something into the system, which is just this little squiggle, it'll slowly work its through. Every second it'll play that rhythm on the next one. And this is like a live system. So I imagine each pipe 1000 has 1000 memory states, and it releases them. It's a living object in a way, but it'll die if there's nothing coming in. So most of Mac's programs run from top to bottom, but once they get to the bottom, it's up to you to put this feedback loop. So notice how it's very the cadence is very ordinary, but luckily you can just enter other random data in the system, and notice how it seems like 2 wiggles are inhabiting this thing. So if you think about the memory space in here, that's it's kind of like 10 variables held with 10 seconds of memory or something like that. It'll just keep on going. I have to, opposite of flood, drain the system, undoing the feedback loop, then things just progress to nothing. And the scary truth of it might be that there's still outputting constantly, but they're just outputting 0. Maybe not, though. This one I think is the same idea. Let's see what it does. I just do one click, and it goes 1, 2, 3, 4, 5, 6, 7, 8. You can see visually. And if I change this is delay, this is pipe. So delay is just one bang. Pipe is more complex. It's like a stream of things within a second. This just waits one length of time and outputs one thing. If I bring down the speed to close to 0, you'll notice it is obsessively fast. And then same as the other program, if you just close the feedback, it drains the system. This is a function. The function is a graphic user interface object that lets you mess around. Oh, I added a new point. Notice if you make a point far enough away from other points, it thinks that you added something. There's probably a message you can send, say like delete 7, and then the 7th point in the system will go away. Notice how I can't take the node and put it before or after the two side nodes. So it's a limited, maybe even a linear function. Maybe that's the whole point of it. And then once you have a system you like, I don't know why some are white and some are not, you can just say, 0 to 1,000 states, please output whatever numbers at that place. The range for this right now is that from 0 to 1 with a decimal. So, you can just place these things and then run that function. Over here is a table. Table's similar. This one you have to double click on, which means you got to pull out and look at it. And you just add data points in there. And now you can run that system at any speed. Right now it's going hyper fast. Give me the whole system of 127 points with, probably like 7 times a second. So it's aliasing. I'd have to turn this down, which means adding an integer to the tempo of the metro. See, now it's a nice little dump, 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 dump. 7 times a second, maybe. 3 times a second. So the speed up something that's kind of rational would be around there, maybe. What do we got here? So labs is absolute value. Absolute. Number goes in, and it's basically its minus sign is removed. Over here, notice how the integer doesn't change much, and then the float changes a lot. Over here, it looks like these lists just proves the principle of absolute value. Labs, though, means you can do it with a whole list instead of just an integer. So they make different objects for different, one object for an array, same function as this object for a single data point. So this one's a little tough to comprehend. Let's look at it. This is the whole program. These are the chromatic scale. There's 12 in the chromatic scale. There's 12 notes, and then we're going to play 128 notes. Every time we play a note, that's a second, a fifth, the sixth, seventh, eighth, ninth, 10th, 11th, 12th. We say go fish and go back for more. That's the right output of lfilt. Lfilt has this list right here telling it what it likes, and then what it's not in this list, and it says go fish, which is the right output, which is this feedback loop to say send me something new. So it's going to go through this index, and then if it doesn't find what it's looking for, it's going to say give me something else. If it has a null set here, that means it doesn't have anything it wants. It will cause a stack overflow, which is the equivalent of a crash. Crash is used to crash the computer, but now all they do is just stop the computer and say to you, like, oh, you just committed a logical fallacy. Can you try that again? So let's hear if you can hear it. So that's pretty cool. That's ascending scales or descending. All you have to do is change counter to random, and it'll sound cooler. Yep. These objects down here are make note and note out. They are MIDI objects. There's an internal synthesizer. You can even set it to clarinet if you wanted to. So down here is a bucket. Bucket's pretty cool. Bucket 16 goes to pack 16, and then this is called multi-slider. Whatever my input is the bucket keeps track of like the last 16 inputs, but it runs them down the list. So the first input becomes the second input, and it pushes everything off. The 17th input is discarded. So this moving number set is just pushing the data to the right. Over here is a cycle 5. It's just, is it the same thing as bucket? Feels like it. Yeah, maybe it is. Well, output the first thing. No, it's different. Maybe. Might be the same. Well, let's see. This would tell us if it's the same. It's a little different. Notice how it's not pushing data to the right. It's just putting a new data in the new point. So the 4th point gets renewed, the 5th point, the 6th point, and so on. So it's 2 different ways to deal with data. It's my favorite object, LTOP. It'll just tell you the highest number in a list. And you can say, I want the highest number, the second highest number, the third highest number, the 4th highest number. The 4th LTOP 4 will give you the top 4 in the set. These are the numbers and these are the indexes. And then you could use the data from top 3 and top 4, merge it together and find out what is the 4th most top. Or you could do a top LTOP 1 and then discard that from the set and then send it back through LTOP 1 and discard that from the set, and each time you're finding out the next number in the set by destroying the list. So what we got here is the different objects for making random numbers. Random, best it can, takes a number from this integer, between 0 and this integer.